Imagine giving an AI a single goal, like research our top 3 competitors.
Right. And it doesn't just spit out a generic text blob.
Exactly. It actively browses the web, it scrapes the raw data, runs a comparative analysis, builds a whole slide deck, and then, get this, actually puts a meeting on your calendar to review the findings.
All autonomously. It's pretty wild.
It really is. So welcome to Dataverse by Opal. This is episode number 28, and today we are focusing on Agentic AI and the explosive rise of goal-oriented autonomous systems.
Because we are officially moving past that era of passive chatbots, right? We're stepping into an ecosystem of active digital workers.
Okay, let's unpack this. Because to really grasp how that competitor analysis scenario executes in the wild, we need to completely decouple our current understanding of large language models from what an agentic architecture actually looks like under the hood.
Yeah, I mean, it requires a total paradigm shift in how we view software architecture. Up until now, our interactions with models have been largely single-turn.
Right, very discrete.
Exactly. You input a prompt, the system computes the probabilities to generate tokens, outputs a response, and then it just goes entirely dormant. It has zero agency.
Yeah, it just sits there waiting for you.
But in software engineering, agency means an entity acts with intent within a dynamic, stateful environment. An agentic system doesn't wait for your next prompt.
It receives a high-level intent and just goes to work.
Exactly. It autonomously generates a multi-step execution plan and interacts with external environments to fulfill that intent.
So the language model itself isn't the whole brain anymore. It's almost like having a brilliantly smart but completely stationary encyclopedia sitting on your desk.
That's a great way to put it.
Like you could look up anything, but you got to physically turn the pages and know exactly what query to formulate. Agentic AI, on the other hand, is much more like an eager digital intern.
Right. An intern doesn't just freeze.
Exactly. If you tell that intern, hey, we need a marketing report, they don't just stare at you and wait for you to dictate their keystrokes. They intuitively know they need to open a browser, pull the analytics, format a spreadsheet, and draft a summary.
What's fascinating here is that in this architecture, the LLM is no longer the entire application. It is merely the reasoning engine embedded inside a much larger orchestration loop.
Oh, interesting. So it's more of a modular thing.
Very modular. The agent is a system comprised of a goal interpreter, a planner, an executor, a long-term memory store, and a tool adapter.
So the model, whether you're using like GPT-4, Claude, or a fine-tuned Mistral instance, is just the cognitive core.
Exactly. It's just processing the logic at each of those nodes. It acts as the routing mechanism, deciding which module needs to fire next based on the environment's feedback.
But an intern has human common sense. If a machine doesn't have a human holding its hand, how does it logically bridge the gap between a vague command like write a report and a highly specific technical action?
Like writing a Python script to query a SQL database.
Yeah, there has to be some structured framework driving that autonomy, right?
There is, and it operates through a continuous closed-loop engine. It typically breaks down into 5 distinct mechanical stages.
Okay, lay 'em on me.
So stage 1 is goal interpretation. The orchestration layer receives your natural language instruction and translates it into a formal system-level objective.
It basically defines the parameters of success.
Right. But stage 2 is where the actual heavy lifting begins. That's task decomposition.
Okay, breaking it down.
Yeah. The reasoning engine takes that massive abstract goal and fractures it into a sequential dependency graph of subtasks.
I want to push back on that a bit, actually, because task decomposition sounds incredibly fragile to me. How does it guarantee that the sequence makes logical sense?
Well, it doesn't just guess.
Because it can't just guess the order of operations.
Yeah.
It would fail instantly.
Right. It uses advanced prompting architectures to force logical progression. The most prominent one is REACT, which stands for reasoning and acting.
REACT. Okay. How does that loop work?
Under a REACT framework, the system is constrained to a strict internal loop. It must generate a thought, then an action, then observe the observation.
So it's heavily structured.
Very. So the internal log looks something like this. Thought, I need competitor pricing data. Action, execute a web search.
Makes sense so far.
But then, observation, the target website dynamically loads its pricing tables via JavaScript, so the basic HTML scrape returned empty tags.
Ah, the classic scraper block.
Exactly. So then it goes back to thought. The basic scrape failed. I now need to write and execute a headless browser script using Playwright to render the JavaScript and extract the table.
Oh, wow. That is wild. It's literally thinking out loud to validate its own logic path.
It really is.
And I guess that transitions perfectly into the third stage, which is tool selection and invocation. Because to execute that playwright script, the LLM needs access to tools outside of its own weights and biases.
Precisely. It has to physically interact with the software environment. The language model alone cannot ping a server or read a database.
Right, it's just text.
Yeah. It needs access to external APIs, Python REPLs, or cloud functions like AWS Lambda.
So it's actually reaching out and touching other systems.
Exactly. When the agent reaches the execution phase, it dynamically reads the OpenAPI specifications of the tools available to it.
So it knows what levers it can pull.
Right. It maps the required inputs, formulates the precise JSON payload required to trigger that specific API endpoint, executes the network call, and parses the response.
Wait, so if it encounters a broken web link or fails a task, it doesn't just crash and throw an error code, it actually replans.
Yes, and that is the fourth stage, contextual feedback and replanning.
Because anyone who has ever maintained an API pipeline knows things break constantly. Endpoints change, authentication tokens expire, you get like 400 bad request errors all the time.
If we connect this to the bigger picture, this real-time self-monitoring and execution branching is the defining characteristic of agentic autonomy.
Because a traditional Python script hitting a dead API link just throws a fatal exception and dies.
Exactly. A hard-coded automation pipeline shatters the moment an environmental variable changes. An agent dynamically routes around the failure.
It just tries another way.
Right. Rather than terminating, the agent ingests the error code as a new observation in its React loop.
So if it gets a missing parameter error,
it reads that error string, cross-references it with the API schema, rewrites the JSON payload to include the missing parameter, and fires the request again.
That level of resilience requires serious context tracking, though. But doesn't an agent's context window eventually fill up?
That's a huge challenge, yes.
Because if it is running a loop of 100 failed API calls and error codes, it can't hold all that in its immediate working memory. It would just overflow and lose track of the original goal.
Which brings us to the fifth and most critical stage, memory management.
Ah, okay. How do they handle that?
To prevent context window overflow, agentic systems utilize a hierarchical memory structure. They use high-speed key-value stores, like Redis, for short-term scratchpad memory.
So that's for keeping track of immediate variables, like the current step in a loop.
Exactly. But for episodic and long-term memory, they rely on vector databases, things like Pinecone, AIIS, or Weaviate.
So it's effectively archiving its own experiences.
Exactly. When an agent attempts a complex task, it takes the outcome, converts that semantic experience into a high-dimensional vector embedding, and stores it in the database.
So it remembers what worked and what didn't.
Yes. If you ask the agent to run a similar marketing report 3 weeks later, it queries the vector database, retrieves the embeddings of its past failures, and injects that specific context into its current prompt.
Wow, so it inherently remembers that the competitor's website blocks standard scraping, so it completely skips the failing step and immediately deploys the headless browser.
Exactly. It builds compound operational intelligence over time.
It's just incredible. But if we move from the theory into the practical landscape, building a system that manages React loops, vector embeddings, and JSON payload execution sounds like a massive infrastructure headache.
Oh, it absolutely is if you're building it from scratch.
So who is actually abstracting this layer so developers can deploy these systems easily?
Well, the major cloud providers are aggressively pushing agentic infrastructure right now. Amazon's Bedrock agents, for example, allow developers to define the goal state, and the infrastructure natively handles the API tool invocation.
Via AWS Lambda, right?
Right, while also tying into Amazon Kendra for secure retrieval augmented generation across internal data.
So Amazon is making it plug and play. What about Microsoft?
Microsoft is taking a slightly different approach with Azure AI Studio and the Copilot stack. They are deeply integrating with the Microsoft Graph API.
Because Graph maps all the relationships between an enterprise's data.
Right. Graph maps the secure relationships between a user's Outlook calendar, SharePoint documents, Teams messages, everything.
So a Microsoft-backed agent isn't just doing a dumb keyword search?
Not at all. It is navigating the actual security permissions and contextual organizational chart of the enterprise. It can autonomously cross-reference an email thread with a secure PDF, ensuring it only accesses data the specific user has clearance to view.
That is huge for compliance.
Absolutely. And Google is similarly positioned with Vertex AI Agent Builder, natively binding agent flows to Google Workspace add-ons.
But, the enterprise clouds are really just standardizing what the open source community is pioneering.
Oh, without a doubt.
When projects like AutoGPT and Baby AGI launched, it basically proved you could wrap a continuous execution loop around a base model. Now, the open source tooling is getting incredibly sophisticated.
The jump in open source complexity over the last year alone is staggering. Take a framework like Crew AI, for example.
I love Crew AI. It operates on the principle of multi-agent collaboration, right?
Exactly. Instead of forcing one massive LLM to handle research, coding, and quality assurance all at once, which, dilutes its focus, you instantiate a crew of specialized agents.
You basically give them job titles.
Yeah. You assign one the system prompt of a senior data analyst and give it access to SQL tools. You assign another the role of quality assurance reviewer.
And they just talk to each other.
They operate in parallel, passing JSON objects back and forth, critiquing each other's outputs before finalizing the task.
It's an entirely synthetic department working in tandem to reduce hallucination rates. It's brilliant.
And then you have tools like OpenDevin, which is a fully autonomous coding agent.
Oh, yeah, that one is fascinating. It effectively drops an AI directly into your terminal environment.
Right. It can traverse your file system, read your code repository, identify a bug, write the patch, run the unit tests, and execute the git commit entirely on its own.
It's essentially a synthetic junior developer.
And that leads to use cases that fundamentally alter business velocity. DevOps teams are deploying agents that autonomously triage incoming server alerts, SSH into the affected machine, and restart the necessary daemon.
Without even waking up a human engineer.
Exactly. And finance teams are using them to reconcile complex, unstructured ledger discrepancies across legacy software platforms that don't even have modern APIs.
Here's where it gets really interesting, though. Because these agents are not bound by a strict linear script, they occasionally display what developers call emergent behavior.
Yes, this is a crucial concept.
They find optimized pathways to a goal that a human engineer never explicitly programmed. There was a fantastic example in the source material regarding user onboarding.
The conversion rate example.
Yeah. Let's say you deploy an agent into your software environment with a broad objective, like improve the user onboarding conversion rate.
Which is a very high-level, multifaceted objective.
Exactly. A traditional script would just spit out an analytics dashboard and call it a day. But an autonomous agent goes into the code base and realizes the UI copy on the sign-up screen is statistically causing user drop-off.
So it took action.
Right. So it rewrites the UI copy, then it accesses the backend configuration and adjusts feature flags to remove an unnecessary verification step.
And it doesn't stop there.
No. Finally, it integrates with a marketing CRM and builds an automated email sequence for users who abandon the cart.
It synthesized 3 entirely different disciplines.
Front-end design, back-end configuration, and lifecycle marketing, all to achieve the primary goal, building novel workflows entirely on its own.
It is a profound demonstration of agency, but listening to that scenario and AI independently altering back-end feature flags and modifying production UI copy, it really highlights the sheer operational risk.
Oh, it's terrifying. It's like giving a Roomba the objective to clean the house, but forgetting to tell it not to throw away the dog's food bowl.
Right. The objective is met, but the alignment is completely broken.
If an agent has write access to a production database and it misinterprets a command to clean up legacy data, the results could be catastrophic.
This raises an important question. How do we engineer guardrails that allow for emergent, autonomous problem-solving while preventing systemic destruction?
Because you don't want to stifle the autonomy, but you can't have it deleting tables.
Exactly. The inherent challenges of LLMs, specifically hallucinations, are exponentially more dangerous in an agentic system.
Because if a chatbot hallucinates a fake software library, you just get a weird text response.
Right. But if an autonomous coding agent hallucinates a software library, it might actively try to download and install a malicious package from the public internet.
Which is exactly why you can't just hand an agent root access and walk away.
Never. Enterprise deployment requires strict, multi-layered guardrails. The first layer is granular tool access control.
So, principle of least privilege.
Exactly. You might grant an agent read access to the SQL database, but strictly revoke all write, update, or delete privileges.
What about data cross-contamination?
That's the second layer. It involves memory and tenant boundaries, ensuring that an agent operating on behalf of the HR department cannot query the vector embeddings generated by the finance department's agent.
That makes sense. But what about the execution environment itself? How do developers keep the agent from infecting the host system if it just goes rogue?
That is where isolated sandboxing comes in, typically utilizing ephemeral Docker containers.
Ah, so it's locked in a box.
Right. The agent is executed inside a tightly restricted virtual environment with no access to the host machine's file system or broader network architecture.
So if it messes up, it only messes up the sandbox.
Exactly. If the agent generates a destructive script or gets trapped in a resource-heavy infinite loop, the orchestrator simply kills the container and spins up a fresh, clean environment in milliseconds.
That's a brilliant failsafe.
It is, but the ultimate failsafe, and honestly, the one non-negotiable requirement for high-stakes environments, is the human-in-the-loop checkpoint.
Oh, so the agent is allowed to do like 99% of the cognitive and technical legwork.
Right.
But before it executes a destructive action or pushes code to production, a human engineer receives a prompt to review the execution plan and authorize the final command.
Exactly. Trusting the reasoning capabilities of the model while strictly validating the output payload.
Trust, but verify.
Always. Now, knowing that these architectural frameworks and guardrails exist, the barrier to actually building these systems is lower than most people realize. You don't need a background in neural network architecture to build an agentic workflow.
So if you're listening to this and you want to get your hands dirty building this today, where do you actually start?
Well, if you are a developer comfortable with Python, the industry standard starting point right now is LangChain or LamiIndex.
They handle a lot of the heavy lifting, right?
Yeah, LangChain provides the foundational abstractions for the React loop, tool binding, and memory management out of the box.
Okay, so you just hook it up to a model.
You connect it to a frontier models API like Claude or GPT-4 and use orchestration frameworks like Dagster or Prefect to manage the deployment and monitor the logging of the agent's internal state.
But what if you don't write code? Like, what if you are a product manager or an operations lead who just wants to automate a complex sequence of administrative workflows?
The visual orchestration layer is booming right now for exactly that reason. Platforms like Flowise AI or Langflow provide incredibly intuitive drag-and-drop canvases.
Oh, I've seen those. They look like flowcharts.
Yes. You visually drag a document reader node, connect it to an LLM node, link that to a vector database storage node, and suddenly you have a custom RA agent without writing a single script.
That is wild.
And other platforms like agentops.ai focus heavily on the observability side, allowing you to visually monitor exactly what your agents are doing, how much API compute they are burning, and where their logic paths are failing.
So you literally just draw the logic architecture on a screen, and the platform compiles it into an autonomous digital worker.
Basically, yeah.
So what does this all mean? If we synthesize the mechanics, the ecosystem, and the tooling we've explored today in this deep dive, the core insight is that we are crossing a fundamental threshold in software capabilities.
A massive threshold.
The architecture is shifting from passive systems that require constant human prompting to proactive systems that drive their own execution loops. They take human intent, decompose it into logical operations, and interact with the digital world to make it happen.
And as we said, the barrier to leveraging this technology is evaporating.
Exactly. Whether you're building complex multi-agent simulations in Python or dragging nodes on a visual canvas to automate your weekly reporting, the tools are accessible right now.
Just remember to start building within sandboxed environments. Establish your guardrails and begin transitioning your workflows to leverage autonomous actions safely.
Absolutely. The shift from software as a static tool to software as an active collaborator is irreversible at this point.
It really is. But there is one final larger implication I want to leave you with today.
Okay, let's hear it.
We discussed multi-agent collaboration earlier, like Crew AI, where different agents take on specific roles within your own internal architecture.
Right, the synthetic department.
But let's scale that dynamic outside the boundaries of a single organization. Imagine a scenario where your company's autonomous procurement agent registers a shortage in compute resources. Instead of alerting a human, it autonomously reaches out to a vendor's autonomous sales agent.
A completely machine-to-machine negotiation economy.
Exactly. They query each other's APIs, haggle over dynamic pricing parameters, draft the service level agreement, execute the digital signature, and provision the server space.
And all of it happens in fractions of a second with zero human intervention.
Yes. As these agentic frameworks standardize, how will a high-speed, invisible economy driven entirely by machine-to-machine goal execution redefine our foundational understanding of market dynamics and business logic?
That is a staggering thought. A whole sub-economy operating at computational speeds, completely beneath the surface of our own. Definitely something to chew on. Well, that wraps up our deep dive for today. Thank you for joining us, and we encourage you to keep exploring, keep experimenting, and keep questioning the expanding dataverse.